So good morning, everyone. It's 5:18 Saturday morning, and feels really beautiful out. I think we're going to get a lot of rain this weekend. So be careful and be cautious with everything you do. Drive carefully. So I want to go over two problems here, and the first one was question 9. I was amiss, and I apologize to you for giving you this problem. I think this was too complicated, and we didn't go over this in class enough. We haven't done Excel enough either. But nevertheless, I'm going to make a video and send it to you, okay? So this was question 9 on chapter 5, as you can see here. So it says you have an outstanding, it's a student loan problem, okay? You have an outstanding student loan with required payments. You're going to pay $500 a month on your student loan for the next 4 years. That's 48 months, right? The interest rate on the now they give you the 9%. It's APR, right? And you got to convert that to monthly, right? You are considering making an extra payment of $100 today, right? So you're going to pay a little bit up front there to try to lower the amount of money you got to pay at the end. You know, paying money up front saves you money at the end. This is why a lot of people will pay their mortgage. They make extra payments on their mortgage. If you are required to continue to make payments of $500 per month until the loan is paid off, what is the amount of your final payment? Now, you know what they're doing. That final payment will be lower, right? Because you made that extra $100 payment up front, okay? So that's part 1. And then what effective rate of return expressed as an APR with monthly compounding have you earned on the $100, okay? So let us look at this problem using the spreadsheet. I think that would be the easiest thing. All right, so the first thing you have to do is make a timeline, okay? So this is the way it normally will look. This is the way it would look if you did not make the $100 payment, right? Here you are, look, 500, 500, 48 periods, a $500 a month cash flow. I hope everyone's clear, okay? So what you got to do is you got to basically say, well, if these are the payments I'm making, how much do I really owe in the present? What's the amount of my student loan? This is what you have to first find, okay? It's important to figure out, okay, well, how much do I really have on the student loan? So we're going to use Excel, and here's how simple it is. 48 payments, okay? Now your rate expressed as a monthly rate is going to be 0.75%. Is that clear to everyone? They told you it was 9% a year APR, but you got to divide that by 12, right, and get a monthly rate, okay? So 9% divided by 12 is 0.75%, okay? Here you are making a payment of $500 a month. So this is given, everything is basically given, except you got to make this a monthly rate. So the good news now is you end up solving for the present value, and this is how much your loan is. This is the value of your loan based on these payments, this interest rate, and the number of periods, all right? So it winds up, the value, you took out a $20,092.39 loan, all right? Now, the next thing is, it says, if you pay an extra $100 today, right this moment, you're going to lower your remaining balance, okay? And how much are you going to lower it to? Well, if this is the value of your current loan, you're going to give them $100. So is it clear to everybody right here? Is it clear to everyone right here? If I subtract off $100 right now, I only know now, $19,992.39. So your balance is reduced. Your required monthly payment is not going to change, right? Your payment never changes. You just lowered the balance, okay? So you're going to end up paying off the loan a little more quicker because you, like on a mortgage, you paid a little bit extra up front. And the extra payment is going to reduce the last payment you need to make at the end of the loan. All right, so let's look at the timeline after you make that $100 payment, all right? Now the value of the loan here is not this anymore. It's now this, $19,992 after you gave them the extra 100, all right? And you now make $500 payments. And the question we're asking is, how much is this last payment going to be? Right here. We don't know that, okay? So for the next 47 months, as you can see, you're going to be making $500 payments. And this last payment is going to be some amount which we don't know, which we're trying to find, which would be $500 minus the money we saved in the long run by paying that extra $100 up front. So we have to solve for X, all right? So let's recall that the present value of the remaining cash flows equals the outstanding balance when the loan interest rate is used as the discount rate, all right? So this is kind of like the equation that they're using, all right? And you kind of have to solve for X using Excel here, all right? So basically what we're trying to do is find out what that last payment is going to be. So I'm not going to use this equation. We go back to the spreadsheet again, and you'll notice not a lot has changed if you look at the previous spreadsheet. This remains the same. This remains the same. Now we're solving for the future value, not the present value, because we know the present value after we make that $100 payment. So we just change that to what this originally was, minus the $100 right there. You see that? And we still make the same payment. That hasn't changed. So the only thing that's really changed is basically we changed the present value to $100 less than it originally was. So we get the future value of that last payment, and it turns out to be $143.14. Now that's not the payment. You're going to be making a payment here. We solved for X. Okay, as you can see here, it's $500 minus X, that last payment. So X is what we just solved right here. So what you have to now know is X is $143.14. So if I make a $500 payment, I'm going to subtract that off of the 500. All right, right there. I subtract that off of the 500. And the last payment will be $356.86. So you'll notice by making that extra $100 payment up front, I reduced this last payment to $356.86. I didn't save a lot of money because I paid $100 up front, and basically this should have been, basically I saved about $43 and change, really. All right, because I paid that extra $100 up front anyway. So you can see the extra payment exchanged 100 today for 143 in 4 years. All right. So if we just go through a quick calculation, basically you will see that the APR, and this is equation 5.1, right? This is equation 5.1, right, that we did in the book. And here is 48 periods. Here's the interest rate. So $100 times 1.075 after 48 periods comes out to 143.14. So you can see you do earn a 9% APR, the rate on the loan. All right. So you did earn 9% on your $100 in the money you saved. So that's how that problem is solved. Again, it was a little too complicated. I shouldn't have given it to you. But it's just good to go over and review. So you notice how it was done in 2 parts. Here's the original timeline up here. And here is the modified timeline, because we want to know what that last payment was going to be. And the cash flow over here now is what we originally calculated minus that $100 we paid up front. I hope I'm clear. If anybody has any questions on that, let me know. This was a little too complicated and I shouldn't have done that, so sorry about that.